A few practice problems using the quadratic formula. So going through the steps that we're going to need to go through, we start by simplifying, rearranging, and removing any greatest common factor that's in the polynomial. And in this case, we do have a greatest common factor of 6. So I'm going to take that 6 out, and I'm left with x squared minus 2x plus 1. And that is what I'm going to use, that trinomial is what I'm going to use for my discriminant. So I'm going to use a is 1, b is -2, and c is 1. And so when I plug this in for my discriminant, I have -2 squared minus 4 times 1 times 1, and that's going to give me 0. And when I have the discriminant is equal to 0, I know that there is going to be one solution this time. All right, so what we have here is 6 as our greatest common factor, and then we have the trinomial x squared minus 2x plus 1, and all of that is equal to 0. So I'm going to go ahead and put this into my quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Notice I'm just replacing each of the variables, each of the numbers, with a set of parentheses, and I'm going to plug those values in here. So notice that the negative goes outside the parentheses here because this is the negative b of that formula. Don't forget that. Now I'm going to input my b value, and the value of b is -2. So I'm going to put the -2 on the inside with a negative on the outside. This one's from the formula. This one's from the value of the b. So just don't get tripped up by that. Then I have -2 squared minus 4 times 1 times 1 divided by 2 times 1. Okay, so I'm going to go ahead and simplify this. I get a positive 2 plus or minus the square root of 0, that's what my discriminant was when I simplified there, divided by 2. And if I go ahead and split this, I end up with x is 2 plus 0 divided by 2, and x is 2 minus 0 divided by 2. And when I simplify this, I just have 2 divided by 2, which is 1, and 2 divided by 2, which is also 1. And so that's where I have the same solution. So that's why I only have one solution on this one. So in this case, x is 1. All right, on number 2. So here we have x squared plus 9x equals 52. So first off, we need to get it into standard form. And so I'm going to go ahead and move that over and do that. And it'll already be set equal to 0 at this point because they've already kind of taken that y out and put it in as an equation. So I have x squared plus 9x. I'm going to subtract the 52 over to the other side and have a minus 52 here. And then that leaves me with 0 on the right side. So now I'm already in standard form, and I've skipped down to the part of the problem where I set the quadratic equal to 0. So I've already handled that as well. So I do need to go back and do my discriminant. So a is 1, b is 9, and c is -52. I'm going to plug those in. I get 9 squared minus 4 times 1 times -52. When I plug that in and I simplify, I get 289, which is a number that's greater than 0. So this is going to have two solutions. So I'm going to go ahead and plug it in and start that process. So x is equal to -9 plus or minus the square root of 9 squared minus 4 times 1 times -52 divided by 2 times 1. Notice this time I don't have a negative inside the parentheses, only the one on the outside, because the value of b in this case is a positive number, but there is the negative from the actual formula. So just keep up with those things and be very meticulous, very careful about plugging those values in. All right, so let's go ahead and simplify. So we end up here with the -9 plus or minus the square root, and when we simplified this, we got 289 divided by 2, and we're going to go ahead and split it. So I have x is equal to -9 plus the square root of 289 is 17 divided by 2, and I have x is equal to -9 minus 17 divided by 2. And so then I can simplify. So I have -9 plus 17 is 8 divided by 2, which is 4. And here I have -9 minus 17, which is -26 divided by 2, which gives me -13. So my two solutions here end up being negative 13, and positive 4. Okay, number 3. On this one, it's already set equal to 0, which again is great because that's one less step that I have to do, but it isn't in standard form, so I do need to rearrange a little bit on the left side. I need to have it so that it's 2r squared minus r minus 28. So I'm just rearranging those two terms right there so that I'm in x squared minus or plus bx plus c format. So I'm going to go ahead and do my discriminant. I have a is equal to 2, b is equal to negative 1, c is equal to negative 28. I'm going to plug that in, so I end up with negative 1 squared minus 4 times 2 times negative 28. When I simplify that, I come up with the number 225. That's a number greater than 0, so I'm going to have two solutions for this one as well. Okay, so I'm going to plug this in using my equation here and these a, b, and c values. So I have negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 28 divided by 2 times 2 in this case. So I'm going to go ahead and simplify. I end up with 1 plus or minus the square root of everything under the radical ended up being 225 from my discriminant divided by 4 in this case. Remember, we do have a 2 on the bottom, so it's going to be 2 multiplied by 2 this time instead of the 1. So I'm going to go ahead and split this. I get x is equal to 1 plus 15. 15 is the square root of 225 divided by 4, and I get x is equal to 1 minus 15 divided by 4. So when I simplify this, I get 16 divided by 4, which is 4. And here I get negative 14 divided by 4. And when I simplify that, the simplest that I could make that is negative 7 halves, or negative 3 1/2. I'm going to leave my answer as a fraction just because I generally like to do that because a lot of fractions have those repeating decimals, and just to keep everything nice and accurate, I try to keep the fraction rather than the decimal. This one, decimal or fraction, you'd have an accurate answer. I just want to make sure that I stay consistent. So I'm going to do my x is equal to this negative 7 halves and a positive 4. And so that's where my graph is going to cross the x-axis for this particular function. All right, looking at number 4, another example here. So again, we need to check to simplify, rearrange, remove any greatest common factor. None of that needs to be done. It's already in standard form. Let's go ahead and do the discriminant. So a here is 3, b is negative 5, and c is 2. So I'm going to plug those values in. I get negative 5 squared minus 4 times 3 times 2. Altogether, that gives me 1. 1 is greater than 0, so I do end up with two solutions on this one as well. So we're going to plug these into our quadratic now that we are ready. It's already set equal to 0, so we can go ahead and do that. All right, so we have x is equal to negative. My b value is a negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times 2 divided by 2 times 3 in this case. So we do have another number on the bottom there again. So I'm going to simplify. I have 5 plus or minus the square root, and here where I ended up doing the discriminant, I find out that under the radical is 1 divided by 6. So I'm going to go ahead and split it. I know that the square root of 1 is 1, so I have 5 plus 1 divided by 6, and I have 5 minus 1 divided by 6. So here I end up with 6 divided by 6, which is 1, and 4 divided by 6, which just reduces down to 2/3. I can't simplify it any further. So my final answer on this one is going to be 2/3 and 1. Those are the two places that that is going to cross on the x-axis. All right, and the last one that we are going to do is number 5. So on number 5, we check to simplify, rearrange, or remove our greatest common factor. We don't have anything there to do, so let's go ahead and check our discriminant. So a is equal to 9, b is equal to negative 8, c is equal to 12. Here I end up with, let's see, negative 8 squared minus 4 times 9 times 12. And when I plug that into my calculator, I end up with negative 368. And if you remember with the discriminant, any number less than 0 is supposed to be a no solution problem. But let's just double check, because it's rare that we're going to come across those on some of these practice problems. So let's just double check and make sure that this truly is a no solution problem. So I'm going to take x is equal to negative times, negative and negative 8, plus or minus the square root of negative 8 squared minus 4 times 9 times 12 divided by the 2 times 9. And when I go to simplify this, I end up with 8 plus or minus the square root of negative 368 divided by 18. Okay, and what happens here is we end up with a negative number under the radical. And in Algebra 1, if you try to put that in your calculator, you're going to get an error message. And if you start to think about it logically, there's no way to multiply two positive numbers together or two negative numbers together and get a negative 368. And in order for it to be a square, you would need two numbers that are exactly the same. I couldn't use a positive and a negative number to make that work. So because of that, this is going to cause this to be a no solution answer, because we can't do anything with that in Algebra 1. It becomes a non-real number, and that's not something that we cover until Algebra 2. So in this case, we're going to have a no solution for number 5.